would like to show a few slides which have been loaded. Somebody can, it's got it. Thank you very much, Sir Peter Gluckman, for inviting me here to this very interesting meeting. I see the role of the scientific advisor as trying to help the country and the government in whatever way possible through science inputs. Inevitably, the perspective of providing this advice is going to be determined by the country you come from. I come from a pretty large country, which is thank you, an economically developing country, but the parts of whose science and technology system are highly developed. So as you can see in the next slide, the science advisory systems in India are extensive. Can I operate it from here? Probably I can. Yeah. There are many possibilities. Science academies have been mentioned. The post of the principal scientific advisor was created in 1999. And there is what we call a scientific advisory committee to the cabinet, which has been there a long time. And from 99 onwards, the principal scientific advisor is the chairman of this committee. And of course, as you can see, there are a lot of other avenues from which the government can get advice. Now, as I can see, the office of the principal scientific advisor and the scientific advisory committee to the cabinet have a multi-departmental role, and that is why SACSI, as we call it, has its members all the secretaries of the scientific departments, the presidents of the science academies, the engineering academy, presidents of the industry associations, and also some other leading scientists and academics. This ensures that the kind of work which SACSI and the PSA's office do doesn't duplicate something which is already going on, because all the stakeholders in the science and technology system are already represented in this committee. Now, the scientific business of the government has already been divided into various scientific departments. It's true, of course, for all countries. But there are things which do not fall in a single department, and there are things which parts of which fall in several scientific departments. Basically, the PSA's office and the SACSI essentially focus on these. And of course, we can take up topics suo moto, but also at the request by the scientific community, and it is from even there basic research topics like photonics or quantum matter physics to things like nanoelectronics, research in education networks, or even applied areas like batteries, additive manufacturing, green chemistry. And there are also some policy issues which concern the entire scientific community, like attracting young people to careers in science, because it's not the responsibility of a single department, and this public-private partnership. And my office is also funded for what I have called synergy projects. It's not a big funding. We take up catalytic projects and then hand it over to the department, which should really be pursuing it fully. Now, as I see it, the scientific advice, as I said, can be suo moto, but it can also be requested by the government, or it can be in response to a new situation or a new global development in science and technology. And also, it should be basically in consonance with the objective of the country. The objective of India is to become a developed country, and then, of course, in a somewhat longer term, to become a knowledge economy. We can use collaboration possibilities, physical connectivity through conferences, like the type we are having here, or ICSU meetings, but also now electronic connectivity which enables institutions to contact For example, the partners in the Large Hadron Collider experiment in Geneva, they were all connected through our national knowledge network to the European Union grid when experiments to look for the Higgs boson were going on. Or there are possibilities of using facilities remotely using such electronic connectivity. Of course, the danger also is this is what William Press, who is the president of AAAS of the United States, says, what he calls the appropriability conundrum. Once you have generated knowledge through basic research, that country can, it may be in any country, that country take maximum advantage for it, which can follow it up by having the capability for applied research and the necessary manufacturing skills. And this is a new factor which has come in because of the speed of information flows which are taking place through the internet. So when we provide advice to the government or tell them to take up things, we have to factor these things in. We have talked of international scientific advice. Many international bodies, there is WHO, then International Panel on Climate Change, ICSU, of course, and so on. And this is one enormous source of knowledge which should really be channeled by the Scientific Advisor's Office to the government. Because these committees, expert committees of these bodies already have experts from many countries. And very often these are issues, climate change has been mentioned. In the latest report of the IPCC, it is clearly shown that in spite of the somewhat slowing down of global warming, there is a better than 95% probability that global warming is caused by humans. This comes from an enormous number of experts who have applied themselves. Then this International Atomic Energy Agency's commission, of which I was a member, we said that two of the greatest challenges for the 21st century are going to be energy security and the climate change threat. And we should look for energy technologies which can mitigate this effort. And also about this Fukushima accident, so much has been written about it. But it's worthwhile realizing the World Health Organization report, which was released last year on the health risk assessment. Of course, it was a bad accident, and a large area was affected. The WHO's report concluded the possible impact of the Fukushima accident on the health of population and the affected regions is practically insignificant. So these are all things which are available. I mean, one doesn't have to work for it, it's available. And there is, there are various possible science advisory processes. In our case, we can go only by our own experience. Suggestions which we have made and accepted by the government, like setting up centers of excellence in nanoelectronics or setting up this national knowledge network, or bringing together the capabilities to build an ultra-supercritical advanced, ultra-supercritical thermal plant, which is relatively cleaner carbon technology, can take the steam to very high temperatures. The amount of carbon dioxide that you emit per megawatt that you produce gets proportionately reduced. Of course, the government can also ask us to chair committees. And then, of course, we have the power to set up core advisory groups, which we have done for pre-competitive applied research in technology sectors like automotive. You see, this is a problem in a developing country, which is a problem everywhere, but enhanced in a country like India to increase interaction between academia and industry. And those sectors which are beginning to boom tend to interact with the academic system, and we have set up, we have the possibility of setting up this Society for Cyber Security, or this Rural Technology Action Group. It's a big problem for India, rural development, technology delivery to rural areas, how to bring the enormous knowledge which exists to in the country and we have got these ROTAC centers established by my office in eight IITs. And in my last slide, let me show you a different kind of science advice which is probably more relevant to a country like India. As I said, there are parts of the Indian S&T system which is very highly developed. There are exceptional capabilities there which can be brought forward to be used for other societal purposes. Isotope hydrology technique, which is enormous capability in the atomic system, Department of Atomic Energy. It can be used, it has been used for recharging the aquifers in rural hilly areas. And I see that as a part of the role of this office. Or they build bridges, the defense research guys build bridges for the army which can carry tanks or foot bridges, and they can be used with suitable tweaking modifications, innovations for rural areas where flooding has affected the mobility logistics. So there are possibilities. As I said, the perspective with which one looks at scientific advice may to some extent, to a large extent, depend upon the status of development of the country and the capabilities which it has, and also which is now more and more accessible through international bodies and through international connectivity. Thank you, Chair.